In this lesson, we are going to learn about chords and tangents to a parabola. To start with, we will learn about tangents, and for that we will look at the intersection of a line and parabola. Okay? So, let us see what that means. Suppose we have a parabola and we have a line like this. Now, this line is sort of outside the parabola. Okay? So, we say it does not cut or touch the parabola, correct? But suppose we move this line now and you see that it is just touching the parabola at one point. So, it touches the parabola at one point, then as you might have guessed already, it is now the tangent to the parabola. Okay? A line that touches a curve at exactly one point is a tangent to the curve. It applied for circle, it is also going to apply for parabola. Okay? And finally, okay, if you move the line further, it is cutting the parabola at 2 points, okay, and this we call as a chord of the parabola. Now, one thing to note is that in a circle we would say a line segment joining 2 points is a chord and a line that cuts the circle at 2 points as a secant, but we are not going to make any such distinction here. We will call this as the chord of the parabola. Okay, just keep that in mind. Okay. Now, let us look at the tangent part in a bit more detail. Okay. So, what is the condition for a line to be a tangent? Okay. So, for that we are going to take the standard form of the parabola y squared minus 4ax equals 0, which we know is a right facing parabola like this. Okay. And the focus is at a comma 0. Okay. Now, suppose we have a tangent, okay, to this parabola, and let us say the tangent is equation is y equals mx plus c. Now, the question for us is, what is the condition for y equals mx plus c to be a tangent to y squared equals 4ax? This is the question. Okay. Now, how do we address this? Well, suppose we solve for the intersection point of a line and a curve. Okay. So, let us say that we want to solve for the intersection point or intersection points, right. Then what we would do is, here y equals mx plus c, this y value we will substitute here, okay, and then solve for the common points. Now, technically we should put x1 y1 and then solve, but that will just make it more cumbersome. So, I am just going to directly substitute the y. That means mx plus c whole square will equal 4ax. Now, this means if you expand, you get m squared x squared plus 2mcx plus c squared equals 4ax, or m squared x squared plus 2mcx plus c squared minus 4ax equals 0. Okay. Now, this we can take the x term out, x out, m squared x squared plus x times 2mc minus 4a plus c squared equals 0. Now, this is clearly a quadratic in x. So, let us take this quadratic. Now, this is a quadratic we got when we tried to solve for the intersection points. Now, if this quadratic has 2 roots, then it means there are 2 intersection points, but we want the line to be a tangent. That means for the line to be a tangent, the equation must have exactly 1 root. Now, what is the condition for an equation to have exactly 1 root? Correct, the discriminant must be 0. And what is the discriminant? It is b square minus 4ac equals 0. We put capital B, capital A and capital C because small c is a variable already used in y equals mx plus c equation. Keep that in mind. That is why we have used this notation. Now, the capital B is nothing but 2mc minus 4a. Of course, a also we have used in parabola equation. Okay. So, this means 2mc minus 4a the whole square minus 4 times the capital A is this coefficient of x square, which is m square, and c square equals 0. If you expand this, you get 4m square c square minus 16mca plus 16a square minus 4m square c square equals 0, and this here you can cancel these two terms 4m square c square and minus 4m square c square. So what you are left with is 16a square equals 16mca, and one a can also be cancelled because a is not 0. Remember, a is there in the parabola equation. If a is 0, you don't get a parabola at all. So we can happily cancel a, and of course first we will cancel the 16. After that, if you remove a, you get a equals mc. This is a very, very important condition. This also can be written as c equals a by m. Both are the same. Okay. So this is the condition for a line y equals mx plus c to be a tangent to the parabola y squared minus 4ax equals 0. We will use this many times later. So it's a very important condition to remember. Now that we know the condition for a line to be a tangent, let's look at the different possibilities. Okay, when you have a line and a parabola. That means if you have this parabola and a line y equals mx plus c, what we already know is that if this line is a tangent to the parabola, okay, if a equals mc is a tangent, a equals mc or c equals a by m. Now the question is, what if it is not a tangent? Okay, so that is what we are going to show you next. Okay, if the line goes outside like this, that means okay, the line lies outside. In this situation, what you will have is that a less than mc. Okay, and finally, if the line is a chord of the parabola like what is shown here, okay, then for that, of course you would have guessed it already, it is a greater than mc. Now the question of course is, how do you know that this is less than and this is greater than? A equals mc is a tangent, we all agree because we have derived it. Okay, so to understand this better, because you might get confused and don't know, you may not know which to apply in what situation. Okay, one way of understanding is like this. Okay, suppose okay, you have m greater than 0 and c less than 0. Think about this. You have a line whose slope is positive, c less than 0 means what? The y-intercept is negative. Okay, that means okay, mc is definitely less than 0 because one is positive, one is negative. Okay, now a line like that would look like this. Slope is positive and y-intercept c is negative. You can see that such a line will obviously be only a chord to the parabola. Okay, and that is because if mc is less than 0, okay, then we know that, well, line is always a chord, we know that a is greater than 0 always. Think about it. A is part of the parabola equation, and for this right facing parabola y squared minus 4ax equals 0, a is always positive. Okay. Now if the parabola is left facing, then we will still retain a as positive, but write the equation of the parabola as y squared equals minus 4x. So a is always going to be positive, keep that in mind. That is the convention that we have chosen. Okay, a is always positive, mc is always negative. That means what? A will definitely be greater than mc, not always negative, mc negative in this particular case. Okay, so that means a is greater than mc is obvious, you don't even have to look at the values. So a line with m greater than 0, c less than 0 will always be a chord. Okay, so this is one way to remember that mc is negative, a is positive means a is greater than mc, so therefore it is always a chord. Of course, another way this can happen is if m is less than 0, c is greater than 0. Okay, then again here also mc is less than 0 and the line will look like this. Okay, negative slope and positive intercept, that is also going to be a chord. So keep this in mind. The main thing is a equals mc, but just if you want to know whether a line is outside or cuts the parabola at 2 points, you can use these two conditions. Outside means a less than mc and chord means a greater than mc.